from 8.1, we'll do find a rule, or find the rule. Find the rule for and I'm going to change this to f of g of x. Okay, you've got one from 8.1, and then we'll do... Actually, I'll have to start with that. I think, just so I have the board room to work with. I'll have you do that for a minute. I'll come check your answer. And then I'll do one from 8.5. So if you could start that one. It'll be 8.1, 4, 8, 6. Okay, is there anyone that I can either check an answer or to help you get started on that? That was you, Owen, or? No. Okay, go ahead.
How do you find the rule?
It's just, that's it? I don't know. Let's see, g of x. Just trying to figure out what your shorthand was here. Well, this bottom line, I'm not sure what this top line is. This bottom line is right, but this expression is right. Okay. This part's right. I'm not sure why you're calling that f, because that's not really f. That is f of g. So I think you've got some shorthand here that you're doing, but this expression's right. But you'd have to improve your notation for full credit, I think. Do you have a question?
I don't even know. I don't know. I know, like, if it was like if x was defined, then I could do it, or like I can't do it when it's just.
Right, when it's just an expression. Yep. Yep. Okay, that's a long enough explanation that I might not, and that is not right. Nope, not quite right. That is right. Good.
I know that you do this first, then this, but I don't
Okay.
know how to do it.
All right, Max, can you, I get zoom in on that problem and then. Wow. All right. This was on your quiz already, so you've already had quiz questions like this. We would characterize this as the harder ones of the composition of functions, because I've left this as a variable, so I'm having you find a rule for f following g of x versus f following g of 5, something like that. So this is, I suppose, one of the harder ones. Now, what I would say in general is I've always said convert to nested parentheses. So f following g of x I would rewrite as f of g of x. I've had several students say that they don't need to do that they find that confusing. That's okay, but you'll always see me doing that up here. Okay. Then we work nested parentheses from the inside out. From the early days of order of operations, you're always working them inside out. So when I do that, the first thing I notice, notation-wise, that I recognize is I see this g of x on the inside. So what that means is, this is when I've described these problems, I have characterized them as having an easy step and a harder step. Here is the easy step. I identify g of x, and I come down and I look at my definition of g of x. Well, g of x is x plus 5. So all I'm going to do is to take this and rewrite it as f of x plus 5. All I've done there is replaced g of x with x plus 5. What possible justification do I have for replacing g of x with x plus 5? It's right here, because I said g of x equals x plus 5. That is what I characterize as the easier step. Then, here's where I lose people. there's an x here and there's an x here. And you think they're the same x, and they're not, and that throws you off. So what I say to do is, you know you're doing something with the f function. So come over here and look at the f function, but rewrite that. And I have students that are very successful on these problems now that rewrite this in the way that I'm suggesting. Instead of writing this as f of x, write this as f of the input, because that's what this x means. F of the input, so I come through here, I replace every x with an input. Input squared plus input. No mathematician wants to write the word input all the time, so that's why we just write an x. But in situations like this, you need to distinguish between these x's, and that's how to do it. Then I don't think it's too bad from there on out, because what this tells me to do is, I say, okay, f of the input is going to be input squared plus input. Well, what input am I giving the function? I'm giving it x plus 5. So I just replace each of these with x plus 5. That tells me that f of x plus 5 equals x plus 5 squared plus x plus 5. Oops, that's a lousy parenthesis there. Okay, and this is your answer. Now your authors would have you FOIL that, write it twice, FOIL it, combine like terms. I'm not asking you to do that. I think if you can take it through to this part, you're understanding composition of functions. So you can just leave it like that. Well, I was thinking of having you do g of f for the same one. So why not? Let's spend a minute and now do g of f of x. So I'm going to say part B, find g of, actually I'm going to use the little following symbol, g following f of x. So I will amend this to being part A, and I will change that to part B, and I'll erase some of this so I have some room to work in, but I'll give you a minute to do it. So I would just pause for a minute max and let me come around and check people's answers for G. Okay, now we'll do G following f of x. Now, many students say, hey, I like that notation, I can work with that notation. You're not going to see me doing that. I'm going to change G following f of x to G of f of x. I like that because it's nested parentheses and it forces me into starting the problem correctly. And by that I mean that I start to read the nested parentheses as I work them from the inside out. The first expression that I come to that looks familiar to me is f of x. So what I do then, in what I call the easy step, is I replace f of x with x squared plus x. Why do I do that? Because f of x equals x squared plus x. So it certainly seems reasonable to make that substitution. Again, you'll notice that by the problem that I gave you, f of x equals x squared plus x. So notice that all I've done here is I've replaced f of x with x squared plus x. Here's where I lose people. I see a lot of people get partial credit and then they don't know what to do. They don't know what to do because they get confused between the x here and the x here. They're different x's. So what I say to do is I say, well, you know you're doing something with g. So why don't you take this g function and instead of using g of x, use g of the input. Because that's what that x means. So this says g of the input equals input plus 5. Replacing those x's with the word input. That's the most successful tactic I've seen students use. I think that makes it easier. Because now my input is an algebraic expression. But at least I can come through here, and now I can replace the word input with x squared plus x. So that becomes g of x squared plus x. Am I writing too low for you, Max, or no? No, good. Okay. Everywhere I see input, I'm going to write x squared plus x. So that becomes x squared plus x plus 5. That is the answer to that composition of functions problem. After you just,
it's so hot.
it is. Yeah, it's hot in
Is the
here.
fan on?
No.
Oh, nice and cozy.
By the way, we have no electricity in any of those outlets, so.
I'll find some. I'll generate some. Plug it into a potato. I
That's
bet you know
true.
how to do that.
You can really plug it into the video.
Yes, that would be a good lab. Okay, thank you, Ian. All right. So there are 2 questions up here that you did, and generally there's the same process we're going to apply to all these. I'll start with A, which is f following g of x. F following g of x. My first step, and you're always going to see my first step, is to convert this to nested parentheses. I've had students say, you know what, I don't need to do that, I'm okay with this notation, but you're always going to see me changing f following g of x to f of g of x. And the reason that helps me is that I know that in nested parentheses, I'm working from the inside out. So the first expression, as I try to interpret this, the first expression I come to is g of x. Now, here is what I would call the easy step in this. There's an easy step and a harder step. This is what I think is the easy step. I take this g of x and I replace it with x squared plus 2. So that f of g of x is equivalent to f of x squared plus 2. That, I think, is the easy step in this process. What possible justification do I have to replace g of x with x squared plus 2? They're equal. G of x equals x squared plus 2. Boom. Here's where I lose people. Here's where I lose a majority of people in these. They then have to work with f of x squared plus 2, and students get confused between the x here and the x here in f of x. Clearly, I'm going to do something with the f function. I've got f of x squared plus 2, and I've got f of x here. These x's are different, and I can't say that enough. These x's are different. So here's my solution to that. You know you're doing something with the f function, so come up here and rewrite this. Instead of using f of x notation, I replace each of these x's with the word input. So I change this to, yep, this is where I lose people.
No, I don't.
You don't like how I'm explaining it? Okay. All right. F of the input. Notice I've ignored you and continued on.
I'm not listening. I'm plugging my ears.
F of the input equals 4 times the input. All I've done is taken f of x notation. That's what this x means. The x in the formula means the input. And I've seen students, again, nothing I do works for everybody, but I've seen students that have started to write this on their paper and it looks like it's helping them. Because while this was where I left off in the problem last time, I then rewrote my f of x function here using the word input. Now, what's my input into the f function? My input into the f function is x squared plus 2. So in the last line of my solution, I simply rewrite this and I replace the word input with my problem-specific input. So this becomes f of x squared plus 2 equals 4 times x squared plus 2, and this is my final answer. But definitely, to summarize, change to nested parenthesis notation. That first step is the easier of the 2 steps. You just replace that inner function with its description, with its rule. But now we're doing something with the f function. I strongly suggest you then rewrite that f function using the word input, because then you can see what it is that you're inputting into it. Am I rating too low, Ian, or are we okay?
No, I do pretty well.
Okay. Any questions on that? Okay. I didn't mean to suggest I was going to ignore your questions. I will, because we're about to do g of f of x. So let me talk through the same process again. I'm going to erase all this. But let me talk through it using all the same words. What I do on these, and I have students say, I don't need to do that as a first step. I'm fine with that. G following f of x is equivalent to g of f of x. This is the easy step, where I read my nested parenthesis notation, I see f of x, so I replace f of x with its definition. And I guess I'll look for some interactivity here. What do I replace f of x with on this problem?
F of x, 4x.
4x. This is the easy step. I now have g of 4x. Okay. It's the next part where I lose people. So let me again solicit volunteers.
4x.
Say again? Okay.
But you change the x's to inputs.
Yes, in the g function, I now change all the x's to inputs because these x mean input. So I'm going to write g of the input equals input squared plus 2. Now I go back to where I was working before, and if I may ask you again, just what am I going to write here for the word input now as I go 4x? So that becomes g of 4x equaling 4x squared plus 2. You definitely do. Because it's the 4x that you're squaring. It's the 4x that you want squared. Now, you would probably, in this case, when I went around, I saw a lot of incorrect answers from the standpoint of having parentheses in the wrong place, so you'd probably lose more than a half point for that. Your authors would want you to continue on, and just for grins here, can you tell me what this would be if I applied my properties to this expression? I'm not going to ask you to do this on this problem, but what would that simplify to? It would be 16x squared, because that exponent of 2 is to apply to each one of these factors, so that would be 16x squared plus 2. Yep.
Are you going to give us these variable ones or no?
Oh, absolutely. Absolutely. In fact, I might even skip the ones with the numbers in here this time. Just get right to the good stuff. Okay. Guess we'll pause there with a red button and